Hello everyone, myself Dhanushi and I am pursuing third year engineering at Global Academy of Technology, Department of Artificial Intelligence and Machine Learning. Today I'll be explaining about our mini project titled Handwriting Generation using Deep Learning, which I worked on along with my teammate Hemant P during our fifth semester. In this project, we use Generative Adversarial Network GAN model, which consists of two main components, a generator and a discriminator, which I'll explain further. Let us begin with a small presentation. Problem statement. Creating personalized digital handwriting is a complex and time-consuming process. Traditional methods typically require a large number of handwriting samples, often captured in controlled settings like grid sheets. These samples are processed manually or semi-automatically to extract and digitalize each character. There are several limitations in current approaches. Manual effort, lack of automation, high sample requirement, and limited realism and flexibility. These limitations create a barrier to adopting personalized digital handwriting in fields like e-learning, personalized stationery, digital art, and accessibility tool. Objectives. The aim of this project is to develop an AI-powered system that can generate realistic personalized handwriting using minimal input samples. The solutions will be based on generative adversarial network, which is capable of learning and mimicking complex data distributions such as human handwriting. The key goals which we are focusing on is seamless and realistic generation, minimal sample requirement, efficient and scalable system, and wide adaptability and professional quality output. Proposed model. Our proposed model says that GAN-based approach uses generator and discriminator model for producing realistic handwriting. It trains on large datasets of handwriting samples to replicate user style. Our working criteria encodes the character images and generates seamless transition between letters. Yeah. Our system architecture. System architecture. Generator takes a random noise vector as input. Using its internal layers and learned pattern, generator transforms noise vector into new data samples like a generated image. And discriminator receives two kinds of input: real data samples from the training data set and the data sample generated by generator in the previous step. Discriminator's job is to analyze each input and determine whether it's a real data or something generator has done. The output probability is a score between 0 and 1. The score of 1 indicates the data is likely to be real, and 0 suggests it's a fake. If the generator correctly classifies real data as real and fake data as fake, it strengthens its ability slightly. If generator successfully fools the discriminator, it receives a positive update while the discriminator is penalized. Every time the generator misclassifies fake data as real, the generator learns and improves. Over multiple iterations, the generator produces more convincing synthesized samples. The discriminator continuously refines its ability to distinguish real from fake data. This ongoing duel between the generator and discriminator enhances the overall model's learning process. As training continues, the generator becomes highly proficient at producing realistic data. Eventually, the discriminator struggles to distinguish real from fake, indicating that the GAN has reached a well trained state. At this point, the generator can be used to generate high quality synthetic data for various applications. The project design diagram shows the complete workflow. Input text is provided by the user. The text is then mapped into a characters encoding in the GAN latent space. A GAN model later is trained using these handwriting samples. The model generates individual characters images based on the user's handwriting. These images are resized and combined to align letters properly. Finally, the combined characters are synthesized into a single handwritten output image that looks seamless and realistic. Each phase ensures that the generated handwriting maintains consistency in style, spacing, and the flow. The different phases of project implementation are as follows. User text provides as input and the character encoding using GAN latent space. Then training GAN architecture and generating individual character images. Resizing and combining images, synthesizing final output handwriting. Result. Result. The result of a project showed that the GAN was able to generate realistic and personalized handwriting with minimal input samples. The generated handwriting maintained consistent alignment and spacing between characters. Our system could produce outputs usable for personalized document creation, signature generation, and artistic purposes. The generated image had good clarity, style retention, and smoothness between letter transitions. We successfully validated the system by generating handwritten text using a small dataset of user provided samples. In conclusion, a project successfully demonstrated that generative adversarial network can be used to generate realistic human handwriting with minimal input samples. The system provides a scalable and efficient solution for applications like personalized stationery, e-learning platform, digital arts, and forensic handwriting analysis. The approach reduces the manual effort while achieving professional quality digital handwriting generation. To summarize, we developed a deep learning based system that uses GAN to generate personalized handwriting. Our solution addresses challenge of manual sample collection, limited realism, and high sample requirement in traditional methods. The model provides versatile application across personalization, forensic, and creative industries. Our project is achieved to object of delivering an efficient, scalable, and realistic handwriting generation tool. Future scope for our project. Forensic analysis and handwriting verification in legal context. Personalized handwriting generation analysis can aid forensic experts in comparing suspected handwriting samples with known examples. The system could assist in simulating or reconstructing handwriting under control styles, helping to determine authenticity, forgery, and impersonification in legal documents or evidence submitted in the court. Developing a website to provide user specific handwriting samples on demand. A web-based platform which can be created where users upload a few samples of their handwriting and in return receive a digitally rendered handwriting for any input text. Creating interactive handwriting tools for creative and educational purposes. Interactive tool can be designed where students, artists, or educators can practice writing, create calligraphy art, or stimulate cursive handwriting with feedback and style personification. Integrating with large learning module like ChatGPT. By combining this handwriting engine with models like ChatGPT, users can type a question or a prompt and the model can generate a response in the user's own handwriting style. This offers a unique, personalized, and communication experience. Let us now start with the demo of the code. So here is the code. Let's import required libraries. These are the essential libraries for handling file, image processing, and building deep learning models. Next, defining the constants. Latent DIM tells the size of the noise vector input to the generator. Then image size, which is the final size which each image is resized. Then is batch size, number of images per training batch, which is 32. This is the path of the image zip file, and this is the extracted path of the same file. Then extracting the datasets from the zip file which hasn't been extracted already and avoiding to re-extracting the same file which exists. Let us go to loading and pre-processing images. Here, the all images are found recursively and which are then converted into grayscale and resized to image size, which as mentioned above, and normalizes the range from -1 to 1. Then is generator, which converts a noise vector into 64 into 64 image using upscaling layers. And here, the con v 2D transpose layers increases the image size step by step. The output layer uses tanh to produce value in range of -1 and 1. Next is building the discriminator. Takes a real or fake image and classifies it as real, which is 1, and fake, which is 0. Uses convolutional layers to extract features and flatten them for classification. The important part is training of the GAN. The GAN trains both models in a loop. Each iteration samples real images from dataset and generates fake images from random noise. Trains the discriminator on both. Then trains the generator using. Next is training of the GAN. The GAN trains both models in a loop. Each iterations will sample real images from the dataset and generates fake images from random noise. Trains discriminator on both. Then trains the generator using combined GAN model. The GAN tries to make discriminator believe the generator images are real as well. Here is the simulated GAN training. Executes the full pipeline, extracts dataset and loads and processes images. Builds and compiles generator and discriminator. Constructs the full GAN model. Trains the GAN for 100 epochs. 100 epoch means the model will iterate over the full training data 100 times during the training. Here is the running of the main function. Ensures the simulate GAN training is called when the script is run already. Here the training dataset takes a lot of time, so I have trained the dataset already, so the GAN training is complete. This will be the first part of the output. Yeah, let us begin with the important part. Here we import necessary libraries such as CV2, NumPy, and OS, and zip and TensorFlow. Where CV2 and NumPy is for image processing, and OS Globe zip file is for file handling and zip creation, and TensorFlow is used for specifying code blocks. And yeah, in the constants, we'll mention the image size and size of the A4 size sheet, width and height. And here is the main process, where the process grid image extracts characters from the grid image and save each one in a JPG, converts those images to grayscale and detects the grid using morphological ops, and sorts and filter contours. This crops and resizes and saves individual characters using the given alphabet. The next step is creating a temporary zip file. Zips were all the images from the output folder into a temporary zip file, used for easier processing the later steps. In this step, we process image from the zip file, where we extract images from the zip, convert them into transparent PNGs using thresholding and morphological to create a clean mask. Applies this mark as an alpha channel and stores output in a structured folder and rezip it. The next step is to extract and load the images, where unzips all the final zips and loads into PNG images into directory. And the main part is generating of the handwriting. Now let us proceed with the final step. Here we have to load the samples into the memory. So yeah, first we have to upload image for the small letter. Uh, Next it's for capital letters, and finally for the numbers. These are all the same handwriting samples collected from a single person, and then yeah, this is a cropped zip file for special characters, which is common for all handwriting samples. Yeah, after uploading the four files, it takes the user input and creates a final handwriting in A4 size sheet, and will ask us a text box telling that enter the text to replicate. We have to type what we want to replicate in our own handwriting. So for now, I'll just type my name. Yeah. After that, it generates the handwriting sample into a image in a JPG format, and yeah, this is how the generated handwriting looks, realistic to human handwriting. I hope my explanation was clear, and yeah, Thank you.